Yeah, okay. Once again, hi, my name is Thomas Ehrman. I'm here today to introduce you to the software DASYLab, and yeah, I'm working at the company Mazex. And yeah, just a few words about Mazex. I'd like to mention first is what we do is mainly custom tailored testing solutions, and so we're not only developing this DASYLab software, so we just bring all our competences to the table and create test solutions, turnkey test solutions. And if it's just a single island test stands or a company-wide connected platform that we create, also with mobile test rigs within, we can create that for our customers. And so we not often duplicate test stands, but we make a best fit for customer needs, and that's what we do over the last 40 years. And I think the four groups which are shown on this slide are to explain what different groups we have. So the one that deal with real hardware stuff, that means not only selecting the right measurement equipment, but also creating test frames and putting it all together and integrate it. The software group deals with the automation of such test rigs, and yeah, builds a sophisticated UIs and the automation of these test stands. And that's where also DASYLab comes in. So the other group is one where they were split off our evaluation group. That means when you acquire data with sensors, you often not only need to check if it's working or not, you also have to do offline evaluation of that data. And the vehicle safety group is one that just deals with the evaluation of crash test data and also the ADAS tests. So when you perform the test and you get the data out of the car, you have to apply certain regulations or to the evaluation, and you need to get the stars, and you might know from the Euro NCAP, for example. And we are the only supplier of software that's accredited for such tests, and so we are well known in this area. Yeah, and the other part is the last one is the test data management group, and they focus on evaluating acquired data. That means they create systems where the data is already measured, and create reports out of that, and provide some calculations and formulas for the internal customers of our customers, so to say. Well, the part of our assess, I think, is always to choose the right tool for the right task, and that's something I want to explain later, where DASYLab comes in. Before I do that, I'd like to show some examples we recently published. And okay, this one. This is on the left side. You see the company Stihl. You might know them for the famous chainsaws, but they not only do chainsaws, they also do olive boom shakers and and other stuff that are used in the field. And what we created there was we automated their test setups in all their test facilities, and we built a software that's just one software that's can facilitate all tests and conduct all different tests and test scenarios they need for their devices, their motor devices. And yeah, this is something we did with Backoff. We automate their PLCs and automate the process of generating the programs for the PLC, so that we can use a database of snippets and put them together and yeah, compile it and put this on the specific PLC in a specific test cell around the globe. And so yeah, that's very helpful for them. And they also have an application where they can monitor from their office where these endurance tests are at the moment. The second one in the middle one is we did for this well, Daimler Truck company, the approval of these trucks and what's all around. So all data that's going through the buses and yeah, and only the cargo room temperature measurements and also some others that are acquired with a test fleet of about I think more than 100 trucks driving 24/7, and they acquire data each day, and this data is fed into a data management system we created. And what this system does is it performs basic or some preparation of the data and some calculations and some basic reports, and so that they specific user groups within that company can use that data easily. Well, the next one is a test stand for where we build heavily with metal and a partner. So that means we within Daimler we had a real hall. We have to put stuff in, and this is a steering test rig. That means the front and the rear axle can be measured very precisely without any hydraulic oil. So it's based on the air. So the oh no, don't know the word. The Reibung is very low, and the measurements are very precise. Yeah, we're well connected to partners. So that's what I can show you on a single screen. And so, of course, National Instruments, once we were acquired by them around 2000, and then we later did a MBO, so that's maybe the management buyout again, and we were independently again. So yeah, the reason they bought us was we had some companies. It's GFS, which is now which is well known for the software DASYLab. That's now a part of National Instruments, and the other root of us is the root company is DataLog, which is the mother, so to say, of DASYLab. And yeah, so these softwares are. We have still employees from both root companies, so we're very, would say, expert in these tools. And yeah, well, the ADAS IoT is a group of people dealing with ADAS stuff, and yeah, just for your information. Well, let's talk about the tools we use, and these are our tools. And yeah, well, it's about choosing the right tool for the right task. So if you want to measure high performance and very large data sets, and maybe compile an application, and you want to put it everywhere, then it's maybe LabVIEW or C++ a solution, or the right way to go. And for other reasons, like creating nice reports and having huge huge possibilities to read data in different formats, and Diadem is a plus. And DASYLab comes in when we want to prototype things and also do, well, the customer is kind of not want to deal with any programming. So so let's talk about DASYLab. Yeah, well, we call it is the easy to use measurement software, and the easiness about this is that it comes from just connecting pre-programmed blocks via these wires, and these blocks have specific functionality, and so you don't have to care about how should I program a loop, or should I program a FFT, for example. You just can choose the right block and connect the data to the block, and so that it's a kind of data flow chart you can see here. And yeah, despite of other tools, we also support a lot of different drivers for hardwares, and this is as we love it, vendor independent. So we don't focus on specific vendors. Of course, the NI hardware works very well, it's still supported, but we also have others, like for example the Siemens PLC, or yeah, well, the CAN interfaces from Vector or Quasar or Peak, and yeah, also, yeah, a lot of other hardware, and yeah, maybe we can talk about that later. Yeah. So why to choose DASYLab? And one thing is it's all about complexity, and this complexity, when we make up a space of online and offline applications, and low complexity and high complexity, then I think this is a good picture to show when to select DASYLab. And I'd say that of course you will say now, oh, my application is always high performance and very complex, and I can answer, well, you should think twice, because you, in our opinion, in our experience, 80% of all measurement tasks can be solved with DASYLab, and just a few that really needs that high performance are qualify for LabVIEW. Well, Diadem is a kind of in between, because the DAC module within Diadem is not that popular, but still available, and we can also help there, because we have the Diadem experts. So if you need some help there, we can also provide some services. Yeah, what we say, you should provide on not selecting the right tool. You should focus on the task you currently have to do, and so we do, and yeah, and that's why often engineers choose DASYLab, because it's so easy to just do some data logging or monitoring, or just use that for prototyping. If they just have an idea, just take some sensors and measurement stuff and put that together, they can easily set up a system within minutes. And yeah, so but nevertheless, this software can also and is used customers for real testing applications. So one of our biggest customers is Bosch in Germany, and they do lots of tests with their devices, and still they do that for years now. I think almost 10 years at minimum. So yeah, they love it, the easiness, and I think it's always a discussion about what employees do you have, what skills they have, the skill set of these, and what they like most. And once if they get familiar with DASYLab, they will love it. And so what about DASYLab? Well, as I already mentioned, we have a lot of drivers available. Some examples given here, and of course, lots of mathematic routines for signal analysis, filters, and so controlling stuff is possible. And of course, not in real time because we do it on a Windows machine. We can do real-time tasks, but you need specific hardware to perform that. But this is something I think you already know. Yeah, we can also do layouts and diagrams for the screen or for, well, maybe the printer. And also access to files and databases. And of course, if you want to extend it, you can do this with Python, for example. And yeah, this may be something we can see later also. Some teachers or professors thought this is the great tool for teaching. So this is a book shown here, which is translated into English and Chinese also. And the professor used this DASYLab to teach his topic. So and has a lot of examples made. And one, I think we will. I will take one of these examples and show to you later. Or later is something that's wrong because this is the next slide, and I switch to the software now. Okay, well, this is the DASYLab. I think you can see this now. And what we see here is on the left-hand side, we see lots of different kinds of modules. So with different functionality, and so this so-called your library to which modules are available. And, you see trigger function, mathematics, statistics, signal analysis, control modules, like a state machine, for example. Very handy if you want to create sequences or test stands reacting on certain states. Yeah, different charting possibilities, also files and so. But let's see how we use it. And well, let's start by just using one of these modules. It's a analog input module, and this is by default connected to the audio interface, the microphone I'm currently using. And if I just want to see what I'm talking about is that this is a screen, and then we can just make a connection with the data from this module to this module, and this is the shard result of this module. And this all, and I can just now start, and the audio signal should appear here, and you can see that. And maybe I changed the scaling to something meaningful. So now you can see my audio while I'm talking, and this is nothing special you have to take care about. So, but this will change maybe in the future because if you work with different modules and different analog inputs and measurement hardware, you have to change the you have to set up the specific hardware. So here you see what I've configured for the internal sound card, which channel to use, and yeah, the next one is well, I have to can deal with how many sampling should I use. So this is, I think, 8 kilohertz, and the block size, of course, because these data is packaged into blocks, and these blocks are passed to the next module. And this is something you should learn about when you deal with DASYLab, because it's a very centric concept there. So, but maybe we'd like to get some calculation based on that audio, and so and I like to introduce the FFT module for that, and just again take it from the module panel and just drop it in and just connect this to this module. And we need another charting module. This is here, and we can. This is the kissing feature. I love the name. So just by touching these two modules from the right to the left module, they get connected automatically. And again, we can show the second screen. Well, yeah, I didn't set up anything, so it's just to show how easy it is, and the awareness of this module that now frequency data comes in is something that builds this magic. And well, I think I should also change the scaling here. Do something meaningful. Yeah, now I can see the yeah, well, it's a bit low, the signal, but yeah, that's I don't know why. Maybe that's because too many participants listening. But well, when you see this this screen here, and I change this to maybe something like that, so that we can see more. And if we want to change this to, for example, a waterfall diagram, then we can just select it this way. And now we can see a history of my my speech, and that's that easy, and nothing really complicated to set up. And if you like to change this to, for example, a sonogram, this is also possible. Maybe I have to tweak the settings a bit, because these are often not that helpful when it comes to the audio here. Well, this is something, maybe that value, and maybe we can see some of these. Oh, we can't see because it's my audio. This is well, not really helpful, but we can change that because analog audio is not that good. We just delete that module here and bring in the generator. Well, generators, we can change that without modulation. That means now I have a signal generator for that, and let's say I want to have the specific 440 hertz and a sine curve, then can just select that and connect these again, and maybe this directly runs. Now you see here in this sonogram the 440 hertz, and yeah, well, just an example, and this does not make sense because it's, yeah, too much curves. Yes, so far so good. you can imagine that sometimes you like to have different frequencies to test your application or your device, and then you just can copy. Well, no, I don't have to copy. I can just remove that again and bring in a switch, a single switch. Maybe this. No, this one. Just looking for that one. No. Or I'm sorry, I'm just missing this module. Anyhow, what I can show now is maybe that these generator can also be tweaked by a manual handle. And this is the slider I can bring in. This is something I have to replace with a generator with maybe frequency modulation. And we connect this to the FFT and maybe to that, and this one to this. So what this setup does is I get a control that way, and I have to change the range to a different, let's say, value. And now I should be able to just switch the frequencies. And well, I think it's the relation here. Yeah, you saw that. It's a rectangle. That's not that nice, but anyhow. Now let's see how it works with a sine curve form. And now we can easily change the frequency if we like, and just yeah, you can imagine the rest, right? As simply as that, just have to bring in the right modules, connect them, set it up, and you're done. And if you like to hear what's coming out of this, you can just have this module in and connect it to this data, and don't know how hard this will be now. And if you can hear it, it's maybe because we have, yeah, we can just try it. Well, that's not the right one. Okay, well, I have to change these hardware settings to connect to the right clocks we have in this setup. And now, yeah, you should hear the signal. Not sure if that's also working for you, but I can hear it. And now when I change it, we get a different one. And so, yeah, that's the output. But I think that's not so funny to have that kind of noise, and I delete that again. And yeah, you may ask, well, this is how I can build the setup. It's just by dropping in modules and everything. How can I debug this? And maybe I need to know more details here. And this is something I like to show. And I started again. And maybe you're interested in what's going on this wire here. And you may recognize that this area here below shows this value, and also after that, you can see the frequency here, and here's some basic debug information. If I change it to a lower number, makes more sense. Yeah, and so you can have a dive deep into these signals which are routed across the worksheet. And yeah, the next thing I'd like to show is once you set up your measurement tasks and you maybe give this to a colleague and or just want to roll out this to the test plant or the test field, you like to have a custom user interface, and therefore we created the layouts, and that's something I can show you now. So you get just a blank sheet of paper, and these layouts can be used for screens, but also for designing your printed layouts. And yeah, how's the design process for doing such user interfaces? And well, it's that simple. You have a toolbar here where it states just link graph or link text and line and rectangle. So you have some basic graphical stuff you can use. You can also put in bitmaps and text blocks and tables and so on. And but the easy thing is just if you want to have a graph there, you can make a box, and then you just by double clicking into the box, you can select which module from your worksheet you want to display here in this sheet. And well, I haven't chosen nice names, but I think the sonogram is somewhere here. And the well, this is not the sonogram, but we will see. And the next one, for example, is a time domain graph, and this is, I think, this one. And maybe we want to show also the current frequency we used with the slider, and so we just have the slider here. Oh, this is a small one. We can increase that, and well, so we have also a handle in this interface, and now we can start this. And what we didn't hear because I disconnected the the audio output. So, but you see there's a frequency starting with that value. It's 160 hertz, and I just don't care about the unit values here. And use it that way. And you see, well, this is not that nice. I'd like to get that on the full screen. Well, that is not a problem. We can just enter full screen to view full screen. Control F is a shortcut for that, or the hotkey, and then we get that value. And so it's that easy, and you can configure DASYLab and also the runtime with DASYLab to just deliver this worksheet. The layout is within that worksheet, and you can start it at your test stand, and every complexity behind programming DASYLab is just hidden behind that user interface. Now you may ask, wait, can I stop this measurement somehow? And yes, of course, you can use a key, but if you don't want to use the specific key for that, you can just add a handle and another one. And this is a specific, just a switch. And we configure it to be a start-stop switch. That means DASYLab is started and stopped when using that switch. And I just say OK and bring this window up again. And now there's a switch, and we can just start it here. You see it's just changing the colors, and I can also use stop here, and everything stop. And now start again and stop again. So you can imagine that this is something we can have on our layout then. And I just link another object and take the switch. So now and then I'm into full screen, and I can start the process just by hitting the start node. And now it's running again. Okay, well, these are the basic things you can do with DASYLab. You can imagine when we add some more calculation stuff like adding channels or just multiplying things, you can easily prototype or model some principles you have in mind. And one, for example, I'd like to show now is the one that we is taken from this book I mentioned. This is the just some nicer audio than my one than mine. And well, what's happening here is that this module just reads data from the hard disk. It shows it charted in a time domain. Then it's converted to the frequency domain and shown in the frequency domain, and also played through the analog output. So and maybe I can just start this because it's more interesting to see these waterfall diagrams. Yeah. So some nice jazz and okay. Another thing is, example I can show you now is that is maybe an example for just modeling complex encoding stuff. So if you ever dealt with a channel coding or yeah, encoding digital signals, you might have heard something about the quadrature amplitude modulation that's widely used in the field. And yeah, this is again an example from this book. And well, these are black boxes, and the black box module is something to yeah, you can think of as a subprogram where you can have a kind of separate level to do some more programming and to structure the global worksheet. And what's happening here is that we like to generate some impulses, and these impulses are fed through a comparator and the sample hold module. So that means the output of this, because of the different frequencies of these two channels, yeah, well, this is noise, of course, is some random bit pattern. This is coming out of this module. And this random bit pattern is fed into this, well, I have to change this. And oops. Yeah, well, this random bit pattern is fed into this specific diagram, which does a lot more, like delaying stuff, sample hold again, and serializing, doing some bit calculations. And yeah, I think it's kind of multiplication which is done there, and then it's summed up, and so and added with some noise. And to show what's maybe you know this graphical output is, these are the, if you have the signal space where all the different bits you want to encode is a 16 that means you have 16 spaces where you can have to encode, or you can have a specific symbol for. So these, yeah, well, well, I'm not that expert, but just this is a nice picture, and I want to show that to you. And we can also model here the impact of changing noise. So if we just increase the noise, now you can see these are all separatable. So that is easy to get the symbol when you receive that signal. But and it can be increased if you reduce noise. It's not a lot easier to see the symbols, and but if you change that to a higher level, it suddenly becomes impossible to get the symbol out of this signal. And yeah, well, I like this picture, and maybe you got the idea. From the very simple things to more complex things, this is all possible. What I can show you now is maybe to, yeah, well, can show you some of these. Well, we have our, of course, the possibility to write data, connect to databases, to some messaging through the network, reduction, so that you can average, or you have a shift register, signal switch. I think the signal switch was something I missed, and well, I can show you that. It's not yet. Well, that's not the right one. Well, well, one thing is the special thing section here is having the possibility to send emails, to have a script in place to do anything you want. So that's the Python script interface. It's just here, and you can define parameters and edit the script. Nearly, it's also possible to incorporate external modules, Python modules in that. So the whole, let's say, almost the whole library, the whole different number of different libraries that are available in Python can be used. So yeah, that's of course convolution, transfer function things, filtering. You see, there's endless stuff, and yeah, also these hardwares, and an MQTT or interface also possible, so that you can send any results or any specific data to your MQTT broker, or subscribe to any specific broker and items. And yeah, I think that's for the demo now. And if you have any questions, I'm curious.
Hi, Thomas. Maybe you can mention the different versions of DASYLab, or the modules, the light, the basic, and what's basically the main difference.
Yeah, okay. You're right. The DASYLab comes in 4 different flavors, and from the very basic, that's limited to just one worksheet, to the light version, the full, and the Pro. And well, the difference between these versions is that some Pro functionalities, of course, are not available to the full. That means very seldom you use specific network things and communication stuff. So just a few. And we have a excellent, sorry, excellent overview about the different functionalities on our webpage, and this is well, we see that it's the differences are mainly just having one worksheet running, or having some subsets of the overall functionality available, or having just some drivers available. And I think that's the different flavors. And the pricing is between 500 and 2,500 around euros. So yeah, that's I think that's all I can say now. And, yeah.
Okay. There's a question about how many possible channels are there supported by DASYLab.
Oh yeah. Well, I missed to explain that. Well, this is of course, if you see these modules here, and I'm sorry about that. If we just have the generator, for example, um, and you see this interface, you see this channel 0 to 15. That means you have 16 channels available. This is a limitation that we had per design, since DASYLab is developed in the early 2000s and around, and we never thought that more than 16 signals could make sense. But today, we of course see that, for example, when it comes to temperature or anything that's at a very low speed, it can make sense a lot to have more than 16 channels. And so we implemented a smart multiplexing module that just helps to package multiple channels in one channel. And this is done with some black magic, so to say, so you don't have to care how to extract these values back again. And yeah, so there's no limitation about the channels, but yeah, you will see that it sometimes becomes you lose your oversight of the worksheet if you have thousands of channels, and that's I think that's not the common case. So well, 16 was the first, and we fixed that, or let's say we enhanced that to a magic multiplexing demultiplexing feature with the version 2016, I guess, or yeah, not exactly, but yeah. So that's not the amount of channels. There's no theoretically no limitation, because
Lovely, thank you.
these modules can be cascaded, and so yeah.
Thank you, Thomas. Another question is with regards to programming. So user is asking if some custom programming is needed instead of the reports and interfaces that you already have. Is it possible to do that in DASYLab?
Yeah, that's a good question. The part of that I just came across is this module. This is the Python interface, and well, you can program everything you want, and if that's not enough, and of course you may have some code already that's C-based code or some other DLLs or whatever you want to use, then we have a extension toolkit which is for free, and you can create your own modules that can be just imported into this bar, into this panel here, just like any others. So this module, the Quasar, for example, is the one that was created with this extension toolkit. Yeah. So, and also we if you not want to program something, or but you're just missing something, we are also providing services for doing that, and yeah, services for DASYLab to creating such modules, services for diadem and other things. So yeah, that's you can ask us if you don't want to program yourself, but you need that interface or a driver for a specific hardware. Yeah.
That's good to know. Definitely, definitely good to know. The last one I'm seeing currently is what are the main differences between DASYLab 2020 and 2022? So I guess there have been some
Yeah.
improvements and some compatibility with the latest Windows.
Yeah, exactly. That's the main thing I think. We have to take care about new APIs within Windows. So that means today multiple screens are common, very common, and they often have a high resolution. And if you once did programming based on a resolution that was common in 2000, and then you have to change that to something different, to high DPIs. Yeah, that I think that these are the main changes in these versions, and also, of course, the support for Windows 10. And I guess, as far as I know, Windows 11 is also supported. And yeah, we did. Yeah, of course, often from version to version, we add drivers for different hardwares, and we added the possibility to have multiple layouts, and this was also a challenge in the past. So when you work at your Office PC and just creating the worksheet and the layout, and then you go to the different screen in the lab, then the layout often needs a lot of tweaks to get it right again, because all this positioning stuff and so was horrible, and to fix again. And now this is done easily, because you can change and set up a specific size for your layout, so that you can switch it later to the right size. And also zooming is something that we did. So when you see this one here, just navigating around and adding a zooming feature, or just using our layouter, well, this just the kissing feature. And well, if it comes to this in the past was very frustrating, because these wires found their way somehow to the next module, but not this nice way here. And where I can show this, I think when we put it there, it's again nice. So the outer router of these wires were also heavily improved. Yeah.